All right, let's talk about Pythagoras' theorem and calculating diagonals. So this line would be considered a diagonal, okay? But it also goes by the name hypotenuse, okay? Hypotenuse, which is the longest side of a triangle. Now let's say you're given A, B, and let's say our hypotenuse's name is C. Well, the Pythagorean theorem tells us that, well, A squared plus B squared is equal to C squared. Or we can think about it as the sum of the two legs squared is equal to the longest side of the triangle squared. Okay. Now there's nothing much to it. That's it. That's literally it. It can become more complicated depending on the question. But let's do an example where we solve the Pythagorean theorem. So in this case, we're solving for x. Now, if you're a physics student, you might be familiar with rearranging formulas or in mathematics. So in this case, we can say, well, a square plus b square is equal to c square. Now, what I'll do first is I'll rearrange. You don't have to do this, but I'm going to rearrange. So in this case, we can say I'm going to put c on my left-hand side. So c would be equal to the square root of a squared plus b squared. So let's do that. Let's calculate c. So a can be either 3 or a can be 4. Okay? It really doesn't matter, to be honest. A lot of people will tell you, well, the height has to be a and the base has to be 4. But it really doesn't matter because the sum of the triangle will always be true if we look at the Pythagorean theorem. So your legs, you need to be able to distinguish, which means tell the difference between the legs and the hypotenuse. If you can identify the two legs, you can do the Pythagorean theorem, placing them on one side and the hypotenuse on one side. How you can calculate hypotenuse is by looking at what is across my right angle. Okay, that's it. So let's see, a squared. A in this case is going to be 9 plus 16. So in this case, we have the square root of 25, which is then equal to 5. Now, if you want to be a bit more technical, since we're calculating a variable, we can say, well, it's actually plus minus 5, but we can reject the negative 5 since the length cannot be a negative value. Okay. Now, this is pretty much the Pythagorean theorem. Let's look at a more complicated example. I'm going to, let's say this one is x, this one is x plus 2, and this one is 14. Now let's make it a little bit smaller. Let's make it 10. Now they ask us to find x, okay? Or calculate x. Now we can do the same thing. We can just calculate the Pythagorean theorem, which is a squared plus b squared is equal to c squared. Let's input what we have. We have x squared as my a, plus x plus 2 squared plus 10 squared. Now I can solve. Let's substitute. X squared. In this case, I have plus, I'm going to expand this. It's going to be x squared plus 2x, no, x squared plus 4x, excuse me, plus 4x plus 4 is equal to 100. I can transfer this 100 to the opposite side, or from right to left. This would be my right hand side. This is my left hand side, and it becomes a negative value whenever you shift between left and right. Okay, so this is going to be x squared plus x squared gives me 2x squared plus 4x minus 96 is equal to 0. Now we can solve. Can we solve this? Let's see. I'm going to use the quadratic formula. I'll put it over here. The quadratic formula. Quadratic formula is quite nice to know, just in general, if you're doing mathematics. So the quadratic formula tells us that x sub 1, x sub 2, so the 2x values is going to be equal to negative b plus minus the square root of b squared minus 4ac over 2a. So now how do we find this a, b, and c? Well, you need to then be familiar with the standard form of a quadratic equation, which would be ax plus bx plus c. In this case, we can find my a that's in front of my x squared. We can find my b, which is in front of x, and my c is my my constant, or my standard variable. So let's input it. Let's say, let's solve for x. Let's solve for x sub 1, x sub 2. So negative b, remember, this one is my b, this is my c, and this one is my a. So we have negative 4 plus minus the square root of b squared, which is 16, minus 2 minus 4 times 2 times negative 96 over 2a, which is 4. Okay, 2 times 2 is 4. Let's see if we can simplify this. We can say, well, x sub 1 sub 2. I'm going to write over here since I just did all of this. Negative 4 plus minus. The reason we have plus minus is since x squared should give me 2 values. Okay, if there's a 2, it means x has 2 roots or 2 values. If there's a 3, x has 3 values. So let's see. Let's do the calculation over here. So 16 minus 8. 8 times negative 96. What is that? Okay, so to do this one, I'm going to say 8 times 6. What's 8 times 6? 48. Okay, 48, and then 8 times 9 is 720. So we can then say 8, 6, 7. I'm going to pull up a calculator to confirm this quick. Okay, so we have 876. And now I need to add 16 to 876. Why is that? Since this is negative 8 multiplying negative 96. In this case, we have 4 plus 8. 4 plus 8 is what? 14. 1 goes over. That becomes 7 plus 1 is 8. So we have 784. Okay, so we have the square root of 784 over 4. And now we can calculate. So I'm going to pull up a scientific calculator, and then let's finish this video. Okay, so here's my scientific calculator. So let's create a fraction first. Negative 4 plus the square root. The square root of 786 over 4. That gives me 6. Oh wow, it's a perfect number. So the first angle is going to be x sub 1 is equal to 6. Okay. And now if I substitute this one value with a minus, I get minus 8. So x sub 2 is equal to negative 8. Now, what did we talk about earlier? We spoke about how the Pythagorean theorem, we're calculating some side length, right? And we know that our lengths cannot be negative. It would be the same as me asking you, hey, can you run negative 2 kilometers? You know, makes absolutely no sense. So we can therefore conclude that our final answer is 6. How do we conclude it? Well, we can test it. We know that the sum of the 2 legs squared should be equal to the sum of the hypotenuse, or the hypotenuse squared. So we calculated for 6. So this is then going to be 6 squared plus x, which was 6 plus 2 squared, is equal to 10 squared. Remember, I'm looking at my triangle over here. Since I calculated x, I can just substitute for 6 and substitute for 6. Now our Pythagorean theorem should be true. Let's see. Well, this is 36 plus, what's that? 84. No, can't be, 64. Okay, that's going to give me, remember, the order of operation PEMDAS, which means I do my parentheses before my exponents. Okay, so I'm going to do the parentheses. So 6 plus 2 is 8. 8 squared is 64. Should be equal to 100. And in that case, we do in fact see 100 is equal to 100. So now we know that this is in fact a right triangle. And that's the whole idea about Pythagoras' theorem, right? I mean, Pythagoras, he was I think, if I'm not mistaken, he was around in 527 BC. Very good mathematician. And actually, to be fair, this was, there's some speculation that this used to be ancient Chinese before Pythagoras. So why we call it Pythagoras' theorem is a bit unknown. Anyway, I mean, it's known, but you get the point. So the point is that if this is in fact true, that a squared plus b squared plus is equal to c squared, then in fact we do have a right triangle. So we can assign this little right angle, which is equal to 90 degrees. All right.